Lesson 11.4, Inscribed Angles. The learning targets for this lesson are that you will be able to find the measure of an inscribed angle, that you will be able to use inscribed angles and their properties to solve problems. As you saw in the geometry sketch pad before you left class before this lesson, there is a relationship between the inscribed angle and the central angle. We'll talk about that a little bit more in a second. Remember, an arc measure is equal to the central angle. So here's the central angle. Whatever that is, the arc measure is the same. This is not true for the inscribed angle, however. An inscribed angle is an angle with a vertex on the circle, and the sides contain a chord on the circle or make a chord on the circle. An arc that consists of the endpoints that lie on the sides of an inscribed angle is an intercepted arc. So what we have here is we have that DEF is the inscribed angle because its vertex is on the circle. It would make a chord, DF. The arc that is from D to F is the intercepted arc. So this is vocabulary that we'll be using throughout this section and the rest of the unit. We should have already explored this theorem in Geometry Sketchpad, so you should have seen a relationship between the central angle and the inscribed angle, that the central angle is 2 times the inscribed angle, or conversely, the inscribed angle is half the central angle. Now, because the central angle and the arc are the same, we also have that the inscribed angle is half of its intercepted arc in terms of its measure in degrees. Or the arc is 2 times the inscribed angle. So let's take, arc, intercepted arc, is 2 times inscribed angle, and inscribed angle. Intercepted arc is 2 times the inscribed angle. Inscribed angle is half the intercepted arc. Let's take a look at example A. The inscribed angle is 20 degrees. Since it is the smaller, the inscribed arc, BD, should be 20 degrees, and so too should the central angle, BCD, be not 20, 40 degrees, because they should be double the inscribed angle, double the inscribed angle. So BD, the arc, is 40 degrees, the measure. BCD, the central angle, is also 40 degrees. Looking at the next problem, they have given us the central angle. The central angle and the arc measure are the same. So this is also 42 degrees. The inscribed angle, so it touches that arc, touches this arc. It's like an ice cream cone. Here's the top. Top is bigger than the bottom. Top is 42 degrees, so this inscribed angle, the angle that's on the circle, is half. It's 21 degrees. So GE, the arc, is the same as the central angle, 42 degrees. GHE, the inscribed angle, is half of it, 21 degrees. In letter C, they give us that angle KLI. So all the way around, this whole thing is 300 degrees. That means that this arc, KI, has to be 60 degrees, because it has to add to a full circle. The measure of KJI, which is the central angle and intercepted arc are equal, is also 60 degrees. The inscribed angle KLI, pay attention to what it's touching. It's touching this arc. This arc is 60 degrees. The inscribed angle is smaller than its intercepted arc. It is half the size, so it is 30 degrees. We'll be solving some of these with equations too. So rather than give you angle measures, I could give you variable expressions that help you build an equation. Let's take a look at the problems below. Here they don't have a central angle drawn in the picture, but we still need to remember that the central angle and the arc measure, its intercepted arc, are the same. Whereas the inscribed angle is half of the intercepted arc, or the arc is 2 times the inscribed angle. Finding measures of arcs and inscribed angles. They want us to find the measure of PRU. So I trace angle PRU. I note that it is an inscribed angle. Its intercepted arc is 118 degrees. So that is half of 118 degrees, or 59 degrees for the measure of PRU. They also ask for the measure of arc SPU. SPU is this full arc. Well, we already know that this part is 118. What I don't know is PS. But if I look back at this inscribed angle, which is 27 degrees, that means that this arc has to be twice as much, 54 degrees, added together with the 118 will give us 172. Unless I added wrong. Let's take a look at letter B. Take a moment to pause the video and see if you can do this one. The first thing they asked for was measure of arc ADC. ADC goes all the way around from here to here. I don't have the other arc over here. I could subtract it from 360, but if I look very carefully, I can see that angle ABC connects to that arc. ABC is an inscribed angle, so it should be half the size of the arc, which means that that arc is 2 times 135 degrees, or 270 degrees. They also asked for the measure of angle DAE. DAE is here. Its intercepted arc is DE, 76 degrees. The inscribed angle, if it was a central angle, it would be the same, but it's the inscribed angle, so it's half of 76, which is 38 degrees. And lastly, the measure of arc AC. Well, AC is this, and we already know the rest of it is 270, so AC has to be 90 degrees, because 360 minus 270 is 90 degrees. This concludes the start of the 11.4 notes, at least for example 1. This concludes example 1 and the introduction to the 11.4 notes.